how cold is not enough.
Hi all, we are going to learn about how to implement the pass one of 2-pass assembler. So for implementing the pass one of 2-pass assembler, we will be requiring of 3 files. First one is the file which includes our program, and the second file is the input.txt which will include the assembly program that is spread as input, and the optap.txt file will be having the opcodes and its mnemonic values. So today we are going to see what is happening in a pass one program. So this is the pass one of 2-pass assembler program. So in the first 3 lines we are including all the header files required for the program to work, and in the main function we have this much items. So analyzing each line by line, in the first line itself we are declaring some character arrays which are the opcode, operand, label, code and mnemonic. Opcode, operand and label are used for reading the inputs from the input.txt, and code and mnemonic character arrays are used to read from the optap.txt. Now we are declaring some integer values that are location counter, start and length, in which the location counter will be having the location counter value, and the start will be having the starting address of the assembly program, and the length will be having the total length of the assembly program. In the next line we are defining some of the file pointers that are used to open the files, and here in this program we will be having 4 files, in which 2 of them are the reading opening in the reading mode, and 2 of them are opening the writing mode. And in the reading mode we are opening the input.txt which is containing the complete assembly program, and the optap.txt which is having the optaps, opcodes, this one, the opcodes and the mnemonic values. And other 2 files are opening in the write mode, and they are the symtbl.txt which will be having the symbols that are in the assembly program and its location counter value, and the out.txt will be having the location counter value along with the complete assembly program. Now entering to the program, the first line fscanf is used to read from the file, and it is reading from the file which is pointed by the file pointer fp1. We can see that fp1 is pointing towards input.txt. So fscanf fp1 will be reading the first line of the input.txt and will be storing the first line, that means the first 3 strings of the input.txt. That means these are the 1, 2 and 3 strings of the input.txt to label, opcode and operand respectively. And now in the next line we are comparing the opcode with the start. So we can see that this column, this complete column will be containing the opcode values. The start, LD, STA, LDCH, etc. are the opcodes that we are considering in this program. So in this line, in this if statement, we are comparing whether the opcode is start or not. So if it is start, we are comparing using string compare function. So if it is start, then it will be equal to 0, and this portion of this if statement is executed. In this portion we can see that the value of the operand is converted into integer. We can see that the operand value here we read from the input.txt is read as a string. Okay, so we cannot assign the starting address. We use the start variable for pointing or equating it to the starting address of the assembly program. So we cannot store the starting address as a alphanumeric value, otherwise a string value. So we are converting that alphabetic value towards an integer using atoi function. So the operand value, here we can see that the operand value is read as 2000, which is as a string. So that string value will be converted into integer and will be saved into the start variable, and this start variable value is again assigned to location counter, so that the location counter value will be starting from the starting address of the program itself. Now we are printing these complete values, that is the label, the opcode and the operand towards fp4. fp4 means the output.txt. output.txt means the complete output of the program, which will be having the location counter value and the complete program. So we can see that a space is given here, /t. It is because we said that we detected that the first line read was start. So for a start line we will not be having any location counter value, so for that we are leaving this space. and the next line we are reading from the input.txt file, that is fp1. Okay, that is what is happening here. Now entering to this while loop. The complete while loop is used to loop along the input.txt file till an end is detected. We can see that it is looping till an end is detected. Till an end is detected, we are looping. So till this line it will be looping. In the while loop we can see that the first one, we are printing a location counter value to the output.txt. So the location counter value will be printed to the location to the fp4. fp4 is output.txt. So the location counter value will be set to that one. And after that, we are comparing whether the red label, that is, this is the column for the labels, and we are looking for whether the label is equal to star star. So we already read this line, now we are in this line, our file pointer is in this line, so we are checking whether the label, this label column, so this one is equal to star star. So if it is not equal to star star, then we can see that the input will be, that is, if it is not star star, then the case is having this one, so the file pointer will be pointing to this one. If it is this one, we can see that this is a simple portion, that alpha, 5, char z and c1 are symbols. So these are not the normal, I mean as other lines. So we have to save these all things to the symbol table.txt file. So fp3 is used to point to the symbol table. So we'll be writing to the symbol table this value, this label and the location counter, the symbols and the location counter value. Now we are reading from the optab.txt using fp2. You can see that using this line we are reading from the optab, and this will be codes and this will be mnemonic values. So codes and mnemonic values. And we are again in the optab.txt, we are looping till we find an end. And in these statements we are comparing whether the red, I mean from the red opcode from the input file is a content in the optab. Okay, we have to check that it is used for incrementing the location counter value by 3. We can only increment the location counter value by 3 if the red opcode, that is the red opcode from the input.txt file, is included in the optab. That is what is happening here. And again we are reading the next line of the optab, and again the loop is executing till we find the end of the optab. After that we are checking whether the red opcode was word. If it was word, that is, we can see that here 5 word 5, so the opcode is 5, and if it is 5 we have to increment the location counter value by 3. And if it was resw, that is to reserve a word, we have to increment the location counter value 3 times to 3 times the value of the operand. That is, we can see that here alpha resw2, so we have to increment the location counter value by 3 times the operand value. The operand value here is 2, which is read as string, and that string is converted into integer, and that is multiplied with 3. So 3 into 2 6. 6 will be incremented along with the location counter value. And then it is checking whether it was resb. You can see a resb here. So if it is resb, then the location counter value is incremented by that much time. If since it is here it is 1, then the location counter value will be incremented by 1. If it was 2 or 3 or something like that, the location counter value will be increased correspondingly. And for the last, we are checking whether the opcode was byte, and if it is byte, then we just have to do an increment, just an increment to the location counter value by 1. Now we are printing those label, the opcode and the operand to the output.txt file, that is fp4, and then again read the next line of the input file, and the while loop again loops till we find the end of the program. That is what is happening in this while loop. And in the next, after executing the complete while loop or exiting from the while loop, we are printing the location counter value, label, opcode and operand. In this state, we are having opcode equal to end, since we exited from the while loop when we found that the opcode was equal to end. Okay. So we will be having opcode equal to end, and its label will be, you can see that from the input file itself, its label will be star star, and also its operand will be star star. So we are printing the location counter value, the label star star, opcode end, and operand star star to the output.txt. Now in the next line we are calculating the length of the complete program using this equation. That is, the equation is the current location counter value minus the starting address of the program. And now we are printing the length of the program in the terminal, and in the final steps we are closing all these files. So now we are going to see how the program is getting executed. So we are having the pass1.c file, that is our program file, and the optab.txt, then the input.txt. Using these files we are executing the program. So we are compiling the pass1.c. We saw that there are no errors, so we are executing it. So what we got is the length of the code is 23, and we can hope that the output files are generated, that are symbol table.txt and the output.txt or out.txt. Yeah, we can see that here the out.txt and the symbol table.txt are generated. So we can open it, out.txt and symbol.txt. So in the symbol.txt we can see that all the symbols in the input file. So I said that the symbols included are alpha, 5, char z and c1. So these 4 symbols are included in the symbol table.txt, and the location counter values also listed respectively. And in the output.txt we are having in this column the location counter value, and the rest of the file is containing the complete assembly language. Okay, this is what is happening in this pass1 of 2 pass assembler. Thank you.